According to the National Electrical Code, or NEC, the house main lug panel board is not permitted to be installed in a multi-family structure unless it is fed from a main breaker. This is because the main breaker serves as the service disconnect for the entire unit, and it must be located in a readily accessible location outside of the unit. In this case, since the house main lug panel board is not fed from a main breaker, it is not compliant with the NEC. The correct solution would be to replace the house main lug panel board with a main breaker panel board. This would ensure that the service disconnect and the house feeder disconnect are grouped together in the same location, and it would provide a more convenient and safe way to disconnect the power to the unit. Let's delve into the reasons and implications of this requirement in more detail. The National Electrical Code, or NEC, sets the standard for safe electrical installations. Its purpose is to protect people and property from hazards arising from the use of electricity. When dealing with multi-family dwellings, the NEC has specific requirements for service disconnects to ensure safety and ease of maintenance. A service disconnect is a device or group of devices that can disconnect the electrical service to a building or a portion of a building. In a multi-family dwelling, each unit typically has its own service disconnect, allowing the power to be isolated for maintenance or in case of an emergency. The NEC mandates that the service disconnect be readily accessible. This means it should be located where it can be easily reached by occupants or emergency personnel without having to climb over obstacles or access locked areas. For multi-family structures, the service disconnect is often required to be located outside the individual unit or in a common area to ensure it is accessible to all relevant parties. A main lug panel board is an electrical panel that receives power directly from the service entrance conductors and distributes it to various branch circuits. A main lug panel board is designed to accept the incoming conductors at lugs, which are terminals that are screwed down to secure the wires. It does not have a main breaker to disconnect the entire panel. A main breaker panel board, on the other hand, incorporates a main circuit breaker that can disconnect power to the entire panel. This main breaker provides a single point of control for shutting off all power to the panel and its connected circuits. In a multi-family dwelling, using a main lug panel board without a main breaker poses several problems according to NEC standards. Firstly, it does not provide a readily accessible service disconnect for the entire unit. If there is a need to energize the entire unit quickly, such as during an electrical fire or other emergency, the absence of a main breaker makes it difficult to shut off the power safely. Secondly, it can create confusion and potential hazards during maintenance. Without a clear and easily accessible main disconnect, electricians or other service personnel may have difficulty isolating the power to the unit, increasing the risk of electrical shock or other injuries. The NEC requires that the service disconnect and the house feeder disconnect be grouped together in the same location. This means that the main breaker that serves as the service disconnect should be located in the same panel as the feeder disconnects that supply power to the individual circuits within the unit. This arrangement simplifies the process of disconnecting power to the unit and ensures that all relevant disconnects are located in one place. In the scenario described, the unit that has a house main lug panel board without a main breaker is not compliant with the NEC. The correct solution is to replace the house main lug panel board with a main breaker panel board. This would provide a readily accessible service disconnect for the unit and ensure that the service disconnect and the house feeder disconnect are grouped together. When selecting a main breaker panel board, it is important to choose one that is appropriately sized for the electrical load of the unit. The main breaker should have an amperage rating that is sufficient to handle the total load of all the circuits connected to the panel, but it should not be so large that it overloads the service entrance conductors. It is also important to ensure that the panel board is installed in accordance with all applicable codes and regulations. A qualified electrician should perform the installation to ensure that it is done safely and correctly. Firstly, ensure proper panel sizing. The amperage rating of the main breaker must match or exceed the calculated load for the dwelling unit. This calculation takes into account the square footage of the unit, the number of appliances, and other factors that contribute to the electrical demand. Refer to NEC Article 220 for detailed load calculation methods. Secondly, consider physical accessibility. The service disconnect, which is the main breaker, must be readily accessible. This typically means it should be located in a common area or outside the dwelling unit. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to actions such as to use tools, to climb over or remove obstacles, or to resort to portable ladders, and so forth. Thirdly, verify appropriate labeling. The panel board must be clearly labeled to indicate its purpose and the circuit it serves. This helps to prevent confusion and ensures that the correct circuits can be easily identified during maintenance or emergencies. Fourthly, check for proper grounding. The panel board must be properly grounded to ensure electrical safety. This involves connecting the panel to a grounding electrode system, which typically consists of a ground rod or other grounding conductor that is buried in the earth. Fifthly, examine the enclosure requirements. The panel board must be enclosed in a cabinet that is suitable for the environment in which it is installed. For example, if the panel board is located outdoors, it must be housed in a weatherproof enclosure. Sixthly, ensure the correct overcurrent protection. Each circuit in the panel board must be protected by an overcurrent device, such as a circuit breaker or fuse. The overcurrent device must be sized appropriately for the circuit it protects, and it must be installed in accordance with NEC requirements. Seventhly, consider the available working space. The NEC requires that there be sufficient working space around the panel board to allow for safe and easy maintenance. This includes adequate clearance in front of the panel and sufficient headroom. Eighthly, verify compliance with local amendments. Local jurisdictions may have amendments to the NEC that are more stringent than the national code. It is important to check with the local authorities to ensure that the panel board installation complies with all applicable requirements. Ninthly, inspect wiring methods. The wiring methods used to connect the panel board to the service entrance conductors and branch circuits must comply with NEC requirements. This includes the type of wire used, the size of the conductors, and the methods used to terminate the wires. Tenthly, maintain documentation. Keep records of all panel board installations, including the panel board size, the main breaker rating, and the circuit directory. This documentation will be helpful for future maintenance and troubleshooting. In addition to replacing the main lug panel board with a main breaker panel board, there are other steps that can be taken to improve the safety and reliability of the electrical system in the multifamily dwelling. Firstly, inspect all wiring and connections. Ensure that all wiring is in good condition and that all connections are tight. Loose connections can cause overheating and increase the risk of electrical fires. Secondly, test ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. Test all GFCIs regularly to ensure that they are working properly. Thirdly, install arc fault circuit interrupters, or SIs. SIs are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. Consider installing SIs in all circuits that serve living areas. Fourthly, upgrade outdated wiring. If the wiring in the multi-family dwelling is old or outdated, consider upgrading it to meet current NEC requirements. This can improve the safety and reliability of the electrical system and reduce the risk of electrical fires. Fifthly, provide adequate surge protection. Surges are sudden increases in voltage that can damage electronic equipment. Install surge protectors at the service entrance and at individual outlets to protect sensitive electronics. Sixthly, educate occupants about electrical safety. Provide occupants with information about electrical safety, including how to identify and report electrical hazards. Encourage occupants to use extension cords safely and to avoid overloading circuits. Seventhly, conduct regular electrical inspections. Schedule regular electrical inspections by a qualified electrician to identify and correct any potential problems. Regular inspections can help to prevent electrical fires and other electrical hazards. Eighthly, maintain clear access to electrical panels. Ensure that electrical panels are readily accessible and free from obstructions. This will allow for quick and easy access during emergencies or maintenance. Ninthly, use proper lighting in electrical rooms. Provide adequate lighting in electrical rooms to ensure that electricians and other service personnel can see clearly when working on electrical equipment. Tenthly, keep electrical panels clean and dry. Keep electrical panels clean and dry to prevent corrosion and other damage. This will help to ensure the reliability of the electrical system. Replacing the house main lug panel board with a main breaker panel board is essential for complying with the NEC and ensuring the safety of the multi-family dwelling. By following the recommendations outlined above, you can further enhance the safety and reliability of the electrical system and protect occupants from electrical hazards. Remember to consult with a qualified electrician to ensure that all work is performed in accordance with applicable codes and regulations. When dealing with multi-family dwellings, the NEC emphasizes the importance of accessible service disconnects for each unit. A service disconnect is the main switch or breaker that allows you to shut off all power to a unit. It's crucial for safety during emergencies or maintenance. The NEC typically requires these disconnects to be readily accessible, often located outside the individual unit or in a common area. This ensures that anyone needing to cut off power can do so quickly and safely. A main lug panel board lacks a main breaker. It's designed to distribute power from a source that already has a disconnect. A main breaker panel, on the other hand, includes a main breaker that serves as the primary disconnect for the entire panel. The NEC typically doesn't allow main lug panels as the service disconnect in a multi-family dwelling because they don't provide a single, easily accessible point to shut off all power to the unit. The main breaker acts as that critical disconnect. Replacing a main lug panel with a main breaker panel ensures compliance with the NEC and enhances safety. It groups the service disconnect, a main breaker, with the house feeder disconnects, the breakers that feed individual circuits within the unit. This simplifies power isolation during emergencies or maintenance. Firstly, the amperage rating must be adequate for the unit's load. Secondly, the location must be readily accessible to all relevant parties. Thirdly, clear labeling helps identify circuits quickly. Fourthly, proper grounding prevents electrical hazards. Fifthly, the enclosure must be suitable for its environment. Sixthly, each circuit needs appropriate overcurrent protection. Seventhly, adequate working space around the panel is crucial for safety. Eighthly, local code amendments must be followed. Ninthly, wiring methods must comply with the NEC. Tenthly, accurate documentation aids future maintenance. In addition to the panel replacement, inspect wiring, test ground fault circuit interrupters or GFCIs, install arc fault circuit interrupters or RFCIs, upgrade outdated wiring, provide surge protection, educate occupants on electrical safety, conduct regular inspections, maintain clear panel access, ensure adequate lighting, and keep panels clean and dry. These steps contribute to a safer and more reliable electrical system.